Okay, grab your Chapter 5 packet. Chapter 5 Pre-Calc, Day 2, Trig Identities. Open up to the, it's kind of like the worksheet, the next page at where we left off the other day. It says we're going to solve for all values. All values mean everything under the sun. We're going to have to remember a few things. We're going to have to remember our STC. That is going to come into play. And then we have to remember that coterminal angles can continue to go around 360 degrees. We'll kind of take a look at that as we progress through here. First thing we're going to do is we need to solve this, and you're going to go through all of your. Now we're going to need to think about factoring a lot for these problems. So these are going to be kind of a combination between factoring, stuff we learned from Chapter 4, and we'll also put into play the stuff we learned in the beginning of Chapter 5 with the trig identities. So I recognize this as taking a cosine out. I'm going to factor out a cosine, greatest common factor, and I get myself to this spot right here, and boom, I can apply the zero property where the cosine of x equals 0, or the sine of x, I'm going to go ahead and go right to a half. Now you got to remember that the cosine, when can the cosine be equal to 0? Remember the cosine is x coordinate, so we could say it's at 90 degrees. We could also say that it's at 270 degrees. Okay, remember our unit circle, so we're using all of those skills that we had when we had our x coordinate, y coordinate. So all of this stuff is in play, and then 0, -1. So I have 90 and 270. But when they say all, you have to go and say plus 360k, where k is an integer, because it's going to be at 450 and it's going to be at 360 around and around and around, or backwards around. And we're going to say here plus 360k as well. So when they say all, you're essentially going to add on 360k for these values. Some of you might be thinking, well, 90 to 70, 90 to 70, and then back up another. You could actually do this as 90 plus 180k, but there is nothing wrong, and that would solve it, because 90 plus 180 is 270. And then another 180. So that's a little bit different because it is a quadrantal, but there's nothing wrong with this answer right here. So when they say all values, you kind of need to add on that 360k. And then we're back to reference triangles as well. When is the sine equal to a half? And I think we know that that's 30 degrees. So x is 30 degrees. But we got to remember, it's 30 degrees in quadrant 1. It's also in quadrant 2 because it's positive. So we're chilling in the STC. So I get 30 degrees plus 360k, where k is an integer. So we would keep going around and getting all of the coterminal values. But it's also a 30-degree reference angle in quadrant 2, which is 150. And then we would add on our 360k. So here's the 4 answers that make this one true between here and here. Now, if you look at the back page and some of your problems in your homework, it's going to say find the values between 0 and 2 pi, or between 0 and 360. So if they ask you to solve for all values of x between 0 and 360, the answer is 30, 90, 150, 270. Okay? So the moral of the story is factor whenever possible, use the zero property, and then solve. We're right back to Chapter 4 where we did some of this stuff. This is number 6. It's up there. Please, let's not overthink this now. Tangent of x equals 5. The tangent is equal to 5. So you're thinking about the idea of You're thinking about the idea of inverse tangent now, so you would want to do x equals the inverse tangent of 5, because the tangent can be 5, tangent can be anything. And when you plug that into your calculator, I think you get like 78.7 degrees. But you also have to remember that it's going to be quadrant 1. Here's my quadrant 1 answer, but it's also going to be quadrant 3. So you do 180 plus 78, because we would go around to our 78.5 here, and we would get, what is that, 258.7, whoa, 0.7 degrees. And that would be, again, that's if it was between 0 and 360. Again, we could add on 360k and say, hey, here's my 78, I'm going to spin around again. You could just keep doing that where k is an integer, and you can do the same thing here. But just like with that first one with the 0, with the cosine being 0, we actually could just do 78.7, and because the period of tangent is 180, the beauty of tangent is this would work every time. I have no problem with this answer. I have no problem with this answer. Okay, once we get a little bit more comfortable with these, I think you'll maybe pop over to this guy. But there's nothing wrong with finding the quadrant 1, find the quadrant 3, and then this just means circle around, circle around, circle around. Next one, I've got a cosine squared and I've got a cosine. Whenever you have a cosine squared and a cosine, you want to think about, can I factor? So the first thing I'm going to do is get this equal to 0. 6 cosine squared x plus 5 cosine x minus 9 equals 0. Whoa, that's not minus 9, that's minus 6, duh. Let me clear that out. So we've got, what, 6 cosine squared x plus 5 cosine x minus 6 equals 0. And then we want to factor, because we have cosines and cosines. These factor just like anything, and it's 3 cosine, and it's 2 cosine, and I think I want to get 9 and 4, so I'm going to get 3 and 2. So if you want to factor by grouping, go ahead. But we're going to end up with this being a plus and this being a minus. So I get here's my 6 cosine squared, and then I get plus 9 cosine x minus 4 cosine x. That's my 5 cosine x, and then minus 6. So again, it might take you a little bit longer to factor it. Not a big deal. Set them both equal to 0 and solve. Cosine x equals 2/3. Cosine x equals negative 3 over 2. Again, cosine x equals 2/3. We're talking about positive, so we're talking about quadrant number 1 and quadrant number 4. Get your reference angle by using the inverse cosine of 2/3. And I get 48.2, about 48.19. So x is equal to 48.19 degrees. Again, we're going to spin all the way around the circle. So I go plus 360k, just means go around again, go around again. So that's my quadrant 1. My quadrant 4 will be, I got to do 360 minus that value, because I'm going to be down here with this reference angle, and I'll be x equals 311.81. And then I go around again, 360k. When it asks for all, you're just adding on 360k. So those two are answers for sure. And then we head over here and we say, well, when is the cosine negative 3 over 2? Well, when is the cosine negative 1.5? It can't be. And if you type it into your calculator, you get an error, does not exist. So these are the only two answers that we have. And then we have to circle around. So if you have cosine squared and cosine, sine squared and sine, and then another value, tangent squared and tangent, you're probably going to be factoring. Okay, this is on the back page, and I'll flip over to the back page. So this one looks like not nearly as much fun. Now, a key that you're looking for in a problem like this is you have a secant squared. So if you go off of the 4 keys that I gave you, can I change the sines and cosines? Can I use the Pythagoreans for help? Can I factor? Can I distribute? Can I get a common denominator, etc.? You think about changing sines and cosines right away, but what you want to recognize here, and you will when you get better at this, is secant squared. If you remember the Pythagoreans, secant squared, if you grab your lavender colored sheet, is equal to tangent squared plus 1. And that comes off of the Pythagorean. So I have a tangent and I have a secant squared. How do you know which one to change? Well, you're allowed to use the Pythagoreans for the squareds. So I can change that to tangent squared plus 1. That's what secant squared is, minus tangent of x. I'm going to bring this 1 over and make it minus 1 equals 0. Well, now I have tangent squared x minus tangent x, and my 1 and minus 1 go away, equals 0. Well, now we're back to, well, let's just factor tangent of x times tangent of x minus 1 equals 0. And now I set them both equal to 0. But the whole key to this problem is changing secant squared into tangent squared plus 1. Because I know something about secant squared that can change to tangent, that's what makes my life easier. And now I get tangent x equals 1. When is the tangent equal to 0? I think that's the y coordinate over the x coordinate, if I remember correctly. So when is the y coordinate 0 and the x coordinate 1? I think it's 0 degrees and then 180 degrees. Again, tangent has a period of 180. So we could just say 0 plus 180k, but I have no problem with you solving for both of them and then finding this guy. So this is a correct answer. Or I could just say 0 degrees plus 180k. I'm going to go ahead and go with this one. I know it's a bit of overkill, but that's okay. And then the other one, when is the tangent equal to 1? And if you do inverse tangent of 1, and if you think about, well, when is the opposite over the adjacent equal to 1? You could do it on your calculator, or you could remember that we have a 1 square root 2, and I think this is 45. And when is the tangent positive? STC, or 135. And then again, I could do both of these plus 360k. Plus 360k. Oh, no, this crud. I don't need 360k on this one because it asks me for the interval from 0 to 2 pi, which would actually mean this can go away, this can go away. I didn't read the directions. This can go away, this can go away. So in degrees, I would have my answers are going to be 0, 45, 135, and wait a sec. This should be 225. Holy cow, 225. This should be 225. Because quadrant 3, 45 degree angle in quadrant 3. And then I have 180 in there as well. So in radians, it's 0, and it's, what's 45? Pi over 4, and that makes 225 must be 5 pi over 4, and 180 is pi. So since it said just on the interval of 0 to 2 pi, you don't need the 360k's. That's the difference in the answers that you'll see. But the moral of the story here is this is the big moment right here. You need to recognize that we need to change that. So there's a bunch more of these that you're going to work on. I would suggest working through them and then talking with each other in terms of how are we doing, where do we start. The biggest problem is where do we start, and you want to check for these solve ones. Number 1, can I factor? Number 2, can I use a Pythagorean to change a squared into something else so that I can make it go? And that's what we did right here. So I wish you luck. Good times.